Let's look at question 1 to 10 of the 2020 JAMB Chemistry examination questions. Question 1 says, an electron can be added to a halogen atom to form a halide ion with A. 2 valence electrons, B. 3 valence electrons, C. 7 valence electrons, D. 8 valence electrons. So what is the answer to this question? First things first, they said an electron can be added to a halogen atom. First things first, what's a halogen atom? For a halogen atom, don't forget that when it comes to the halogens, now recall that for the halogens, when we talk about halogens, we're talking about those elements in group 7. So halogens are group 7 elements. So group 7 elements. Examples include bromine, Br, fluorine, F, chlorine, Cl, iodine, and etc. So what you have here are some of the basic and most popular halogens. One thing that characterizes these halogens is that they are group 7 elements, which means that they have 7 valence electrons. That means for a halogen, the number of electrons on the outer shell is 7. So you have something like 1, 2, that's 2 electrons, 3, 4, 4 electrons, 5, 6, 6 electrons, then 1, that's 7. So for a halogen, you have 7 electrons on the outermost shell. Now, if they say that an electron can be added to a halogen, if I add an extra electron, let's use X now. If I add an extra electron, X here, in total, how many valence electrons do you have? You have 1, 2, 3, 4, 5, 6, 7, 8. So if I add an extra electron to the halogens, you have 8 valence electrons. So the correct answer here is D, 8 valence electron. That's your answer. Question number 2. When steam is passed over red hot carbon, the substance produced are, so this should be substances, right? The substances produced are, let me correct this. The substances produced are A. Hydrogen and thiazocarbonate 4 acid, B. Hydrogen, oxygen and carbon 4 oxide, C. Hydrogen and carbon 2 oxide, D. Hydrogen and carbon 4 oxide. Now for question 2, you want to note that hydrogen and carbon 2 oxide or carbon monoxide will be formed when red steam is passed over red hot carbon. So the correct answer to this question is actually option C, hydrogen and carbon 2 oxide. So this will be the product when steam is passed over red hot carbon. Question number 3. 3 says there are basic particles from which matter could be made, except this should have been these are, right? Just a typo error. All right. 3 says these are basic particles from which matter can be made, except A. Salt, B. Atoms, C. Ions, D. Molecules. Now from this, we know that some of the building blocks or basic particles of matter includes molecules, atoms, and ions. Salt is not a basic particle from which matter can be made. All right. So the correct answer here will be A. That's salt. All right. Salt is not one of the basic particles. All right. The basic particles include atoms, ions, and molecules. Number 4. Which of the activities is commonly used as a nuclear fuel? All right. So you have these elements here. These are actually elements. So which of these is commonly used as a nuclear fuel? A. Uranium. B. Palladium. C. Actinium. D. Thorium. Now for question 4, the correct answer is A. Uranium. Right? So uranium is a common nuclear fuel because it is less stable. All right? It has less stability, and as a result, it has a great tendency to increase energy. So the correct option here is A. Uranium. Number 5. Tartaric acid is used industrially to A. Make baking powder, B. Make fruit juice, C. Remove rust. D. Dry substance. What is the correct answer to this question? Now, for this question here, the correct answer there is B. Tartaric acid is used to make fruit juice. Now, you want to know that tartaric acid is the acid that is gotten from orange. All right. So, this tartaric acid is actually a type of acid that we get from orange, and it is used industrially to make fruit juice. That's orange juice. So, hence, the correct answer is B. All right. It is used to make fruit juice, and it is gotten from orange. Number 6. Diffusion is slowest in solid particles than in particles of liquid and gases because A. Solid particles have more kinetic energy than the particles of liquid and gases. B. Solid particles have less kinetic energy than the particles of liquid and gases. C. Solid particles have less restriction in their movement than liquid and gas particles. D. The particles in solid are far apart and the cohesive forces between them is or are negligible. Right? So for question 6, what is the correct answer? Now for question 6, the correct answer is B. All right. Solid particles have less kinetic energy than the particles of liquid and gases. Of course, we know that liquid and gases, we know that when it comes to the kinetic energy, gases have the most kinetic energy, followed by liquid and then solid. Okay. And also note that diffusion is the movement of molecules from region of higher molecules to region of lower molecules. As a result, solid particles have lesser kinetic energy than the particles of liquid and gases. So B becomes the correct option. Question number 7. Chlorine consists of two isotopes of mass number 35 and 37 in the ratio 3:1 and has an atomic mass of 35.5. Calculate the relative abundance of the isotope of mass number 37. All right. A 20, B 25, C 60, D 75. So how do we solve this question? Now, to solve this question, we are given chlorine. So number 7, we're given chlorine, right? And we're given two isotopes of chlorine. The isotopes there are chlorine 35 and chlorine 37. So I'll come here and put chlorine, right? Atomic number 17. Then you have this as chlorine 35, and you have an isotope of chlorine, that's chlorine 17, chlorine 37. Let me just confirm that 35 and 37. All right. They said the two isotopes are in the ratio 3:1. All right, and they have an atomic mass of 35.5. Now we're asked to find the relative abundance of the isotopes. All right, we're asked to calculate the relative abundance of the isotope of mass number 37. How do we do that? Now we do not know the value of the relative abundance of chlorine 35. So we'd say let the relative abundance of chlorine 37, so you could also write it this way, right, of chlorine 37 bx. Now you want to take note that if I have the chlorine 35, let's start with chlorine 37. If I take the relative abundance of chlorine 37 as x, and I take for chlorine 35 as y, if you sum all the relative abundances, it should be equal to 100%. All right, and we know that 100% is equal to 100 all over 100, and that gives you 1. All right, so we're working with percentages, so that will be equal to, take this as 1. Let's express y in terms of x. If I have that x plus y is equal to 1, to get y, I'll move x over here. So y will be equal to what there? 1 minus x. We'll have this. So in essence, if the relative abundance of chlorine 37 is x, that of 35 becomes 1 minus x, which is y, as we just showed you here. All right. So what happens next is that the next thing you do is that you multiply the masses All right, that is the isotope. Multiply the isotope by its relative abundance. So 37 times X plus the next isotope is 35 multiplied by its relative abundance 1 minus X will be equal to the relative atomic mass of that particular element. So I'm having 37 times X, which becomes 37 times X plus the second one there, which is 35. That's the next isotope, multiplied by its abundance we got as 1 minus X, of course, expressed as a percentage, right? Then this is equal to the atomic mass of the element, which is 35.5. So this is equal to 35.5. We have this. Let's multiply through. This gives us 37 times x gives us 37x plus 35 times 1 gives us 35. 35 times minus x gives us minus 35x is equal to 35.5. Next up, we have 7x, 37x. Next up, you have 37x minus 35x, and that gives you 2x. Then this one here plus 35, it's equal to 35.5. We have this. Next up, move this over here. We have that 2x, it's equal to 35.5. This moves over here, it becomes negative minus 35. Again, we have 2x is equal to 35.5 minus 35. That gives you 0.5. So this is 0.5. So 2x is equal to 0.5. Divide here by 2. Divide here by 2. This cancels this. So x is equal to 0.5 divided by 2. That gives you 0.25. All right. So hence, the relative abundance of, recall that x represented the relative abundance of chlorine 37, which we've gotten here as 0.25. Your final task is to multiply this by 100%. Okay, remember that we converted this to 1. Initially, this one was actually 100%. We divided by 100. So at this point here, the final task here is to multiply this by 100. So this times 100, and that's equal to 25%. All right, so 0.25 in terms of percentage becomes 25%. So the correct answer there is 25. All right, so let's see which option that is. That is option B, 25. So that's your answer. All right, next up, question number 8. Question 8 says the principal constituent of natural gas is A, methane, B, ethane, C, propane, D, butane. So which of these is the correct answer? For this question there, the correct answer is A, methane. All right. So note that methane, this, of course, the formula there is CH4. Methane, CH4, is the principal and commercial constituent of natural gas. All right. So that's your correct answer. So your correct answer there is A, methane. Question 9. All these are electromagnetic waves except A, white light, B, photon, C, X-ray, D, infrared. What's your correct answer here? For this question here, the correct answer is B, photon, right? Photon is not part of the electromagnetic wave. Instead, it is a unit of energy that carries light and has zero mass. So photon is not part of the electromagnetic waves. Finally, question 10. Question 10, a change in temperature of a saturated solution disturbs the equation between the A, dissolved solute and the solvent, B, solvent and undissolved solute, C, dissolved solute and undissolved solute, D, dissolved solute and the solution. So what's the correct answer for this question? The correct answer for this question is C, dissolved solute and undissolved solute. You want to take note that temperature plays a vital role in equilibrium and the solubility of liquid. So therefore, a change in temperature of a saturated solution will alter the equilibrium between the dissolved and undissolved solutes. All right. So that's how we said dissolved solutes and undissolved solutes. So that's your correct answer. All right. So take note of this. So as usual, I'll leave question 11 for you, right? Provide the answer to 11. Leave your answer in the comment section and I'll tell you if you're correct or not. Question 11 says, what is the volume of energy required to burn completely 45 cm, it should be cm cube, right? Volume of energy, it should be 45 cm cube of methane at STP, that's standard temperature and pressure. A, 135.0 cm, that should be cube, talking about volume. B, 150.0 cm at the cube there, cm cube. C, 45.0 cm cube. Then D, 90.0 cm cube. So you have these options, all right? So what's the correct option here? Is it A, B, C, or D? Leave your answer in the comment section and I'll tell you if you're correct or not. Don't forget to check our JAMB and Pursue Me playlist, right? That will give you access to hundreds of tutorial videos on JAMB classes for JAMB Physics, JAMB Chemistry, JAMB Mathematics, and JAMB Biology. Okay? Okay, guys, so please take note that we have a JAMB WhatsApp group for 2026 JAMB Bites. All right. So if you're writing JAMB for 2026, we have a JAMB WhatsApp group where we do daily revisions on physics, chemistry, mathematics, and biology. So if you're a science student and you want to join our JAMB WhatsApp group, I'll leave a link to the JAMB WhatsApp group in the video description. All right. You can also join our JAMB channel membership to get access to exclusive content for JAMB Bites, or you can get the full JAMB course on our website. Simply visit www.journalimmanu.com/courses and you see the JAMB/WAEC classes. All right. Okay, guys. So if you enjoyed this video, don't forget to hit the like button. All right. Like this video. Also leave a comment. Right, for the comments, I gave you a task, question number 11. Solve it, leave your answer in the comment section, and I'll tell you if you're correct or not. Don't forget to also subscribe. If it's your first time here or you're yet to subscribe, please do what to subscribe, hit the bell icon, and select all so that you get notified whenever we upload a new content. Then finally, ensure to share this video to your friends and their colleagues so that they can also learn. Thank you and see you in our next class.